whenever you're ready.
Okay, good afternoon and welcome to this informational webinar for the Civil and Environmental Engineering graduate programs at Rensselaer Polytechnic Institute. I am Professor Michael Simmons and I'll be the host. Please note that the webinar is being recorded and questions can be asked through the chat box and will be monitored by Mary Kate Scardillo in the Office of Graduate Admissions. So here's a approximate schedule where you can see that we have faculty from each group within the department that will briefly provide an overview of what we're doing within the graduate programs within those areas of concentration. So I'd like to introduce our first speaker, Professor Letchford. He's the head of the Department of Civil and Environmental Engineering.
Thank you, Mike, and thank you for those who have joined us this afternoon. I'd like to welcome you to the oldest civil engineering program in the English-speaking world, and we are in upstate New York, beautiful upstate New York, surrounded by mountains and greenery and lakes. And our interest in civil engineering and environmental engineering is particularly around providing commonwealth, that is to say, the infrastructure that delivers our quality of life and from which all individual wealth is built upon. And you're going to hear this afternoon from the four main areas of research in the department, and you will hopefully get a flavor of the sort of comprehensive research that we cover both in civil engineering and environmental engineering. Once again, thank you very much for participating. We have a long history in civil engineering achievements simply because we are the oldest program. And the Institute was typically founded to build the Erie Canal across New York. It quickly, in New York State, it quickly evolved into building railway lines across the country. And in the 20th century, we have reached worldwide. We are the only department with representation from every continent in the faculty. And so those of you who are joining us from abroad, we really appreciate that you come to a department that has very much an international outlook and an international perspective, and well aware of the impact of civil and environmental engineering on the quality of life throughout the world. So thanks again for joining us, and I'd like to hand back to Mike to keep the show rolling.
All right, thank you very much, Chris. So now we'll move to the geotech program.
Yes, thanks, Mike. This is Shinu Uchida, Associate Professor in Geotechnical Engineering. I'm going to introduce what geotechnical engineering, what we do in terms of research. We have 6 faculties, 6 professors: Tarek Abdoun, Shinu Uchida, myself, Victoria Bennett, Professor Murad Zerkahal, and Ricardo Dobry, and Tom Zimi. Those last 2 are sort of retiring. But because of these last 2 professors, we are very, very well known all around the world. Next slide, please. So what we do in terms of geotechnical engineering, in terms of research, is we are leading geohazard risk assessment. One of our biggest achievement is that we sort of solved the problem with the river failure. And we got an award about 10 years ago. Professor Abdoun and Professor Bennett got an award by American Society of Civil Engineers. Not just that, internationally recognized faculties as well. So we are doing world-leading research. And earthquake geotechnical engineering, we just last summer, we meant to have international symposium at RPI, but because of the COVID, we did remote international symposium. It wasn't as good as the face-to-face, but so we hosted professors from 10 different continents, sorry, not continent, countries, participated as 300 students and so on, talking about liquefaction. So this is how we been recognized and well known for this liquefaction analysis as well. Next slide, please. And environment geotechnics, Tom Zimi, environmental geotechnics is this sort of where we started, and then Professor Zimi is sort of advocate of advancing this topic, and then we do many things. One of them is using centrifuge modeling and monitoring long-term behavior of leachate and other chemical going through underground. And then the last bit is what I do, energy geotechnics. And we we did sort of international collaborations, and then quite recently we published a paper which participated by something like 100 researchers all around the world, and I was sort of leading one of the problems. So and then we get funding from National Science Foundation from US, and not just domestic but internationally. I work with the Department of Energy, US, but also other institute, other continent funding agencies as well. So these are sort of like what we do, and we are a very internationally recognized and leading research. And if you're interested, please do not hesitate to contact me. I need to go, so I cannot stay until late, but then if you have any questions specific about geotechnical engineering, please feel free to contact us or me through email. I'll be responsive. So thanks very much.
Okay, thanks very much, Shun. So now we move to environmental engineering, and we're going to switch to some other slides.
Okay, I'm going to share my screen, I hope. You can all see them, right?
I can see it, Marianne.
Yes.
Okay, okay, so welcome. My name is Marianne Nyman. I'm a faculty in specifically in environmental engineering. I'm an associate professor. I will go through a little bit of history of environmental engineering and RPI and why we do what we do. And then I'm going to introduce my colleagues. We have 3 faculty in the area of environmental engineering. So environmental engineering.
Marianne, did you want to put that in presentation mode?
Yeah, I can do that. Sorry. Here. Sorry. Okay, so the history of environmental engineering is provided in the slide. So sanitary engineering became a subdiscipline of civil engineering, and that was created at the end of Second World War. And the reason was that there were so many emergent environmental problems that required kind of an interdisciplinary approach. So that's how the environmental engineering started. So Professor E. Kilcawley at RPI led the effort to create a new program within the programs at RPI. And this program started in the beginning of 1955, being one of the oldest program in environmental engineering in the US. The first degree at RPI was granted in 1960, and we have currently kind of 2 degrees in environmental engineering, one which is environmental engineering bachelor's degree, but one can also receive a civil engineering degree with environmental concentration. So like I said, we have 3 faculty, 2 research faculty, me, and then Dr. Kilduff, and then we have teaching faculty, Dr. Rodriguez. So I'm going to introduce them briefly. You can certainly email any of us if you have further questions later on. So I'm going to start with Dr. Kilduff. He got his PhD in environmental engineering from U Michigan. His research is water quality and membrane processes, and he's collaborating quite a bit in the chemical engineering department. We have quite famous membrane processes faculty at RPI. He teaches mainly these three courses: physical-chemical processes, biological processes, and environmental process design. So the difference in environmental engineering at RPI is that you actually get a degree in environmental engineering, and hence your classwork will be much more concentrated in environmental engineering classwork. My next faculty is the teaching faculty. He has done, Dr. Rodriguez has done a lot of other things, also environmental consulting, assessment, remediation, other things. And he teaches quite an array of classes from introduction to environmental engineering and applied hydrology and hydraulics to water reuse technologies and applications. Obviously, his teaching load is more than mine and Dr. Kilduff because we kind of conduct research with students. So I got my PhD in environmental engineering from Purdue University. My research topics are mainly fate and transport of organic compounds in the environment. So I look at how they behave in the water, gas, and solid phases. I've done also research in terms of solid and hazardous waste management research, as well as looking into analytical chemistry and how can we do better better methods for detecting problematic compounds in the environment. And lastly, I'm going to show you a slide that relates to my more recent research that's NSF funded. I have one student working on it, and it's more like food and water quality. So in terms of how can we increase the food and vegetable production with less water usage, less pesticide usage, and then kind of engineering manipulation of lighting to increase the nutritional components in food. So I teach mainly environmental chemodynamics, introduction to air quality, and bench scale. So my last slide here is related to specifically what's ongoing right now. So we have different light environments for vegetables, and I have provided here 3 different cultivars of kale: Toscano, Red Boar, and Winter Boar. And you can see how, and they are grown in 3 different environments: field, greenhouse, and growth chamber. We have 2 big growth chambers in our research facilities where we grow these. And then we use Cornell's field and greenhouses to grow these. So I'm collaborating with researchers at Cornell, both on economic side as well as like the plant side. And then we do more the nutritional chemistry related and light functions in our lab. So you can see that depending on the light conditions, so for example, Red Boar has a name, Red Boar. It's very red in the field because the sunlight intensity is very high during summer. But then when you grow these inside, the color is very different, and hence the nutritional components are very different as well. So we are looking at 2 specific kind of compounds that are very important for human eyesight. Those would be lutein and zeaxanthin. And if our bodies are not making those, so what we have to do is we have to ingest those, and that's the only way. So we have to eat our greens, and that's where I'm gonna end. So make sure you eat your greens to protect your eyesight from macular degeneration and other eye problems later on in life.
Okay, thank you very much, Marianne. Our next speaker is Professor He within the area of transportation.
Mike, can you? Okay.
Yeah, I'm working on it here.
Okay, good.
How's that?
Yeah, okay, thank you. So my name is Sean He. I am assistant professor in civil engineering, and I will be my pleasure to introduce our transportation engineering program in civil engineering at RPI. So our transportation program actually has 4 faculty members. Professor Jose Hogan-Villas leads the program, and he directs 2 research centers. His research focuses on freight transportation systems, decision support systems, and humanitarian logistics. Professor Carol Wang, who has research focused on the transportation data acquisition and analysis, transportation econometrics, impacts of emerging technologies and decision behavior modeling, as well as transportation safety.
Yeah, sorry about that.
It's fine. Professor Jake Riley, who has long-term experience in the design, management, and operations of transportation systems. He has a fantastic experience related to the transit system and how to propose different type of planning and policy making to improve transit system performance. For me, my research focuses more on the transportation systems modeling and simulation methods. I also conduct research focused on transportation network resilience and connectivity, autonomous vehicle systems, and electric vehicle systems. Overall, our transportation program has the goal that is to develop theoretical models and data-driven methods for smart and resilient transportation systems. Here you can see that we have 2 centers, the Center for Infrastructure, Transportation, and Environment, and VREF centers of the Excellence for Sustainable Urban Freight Systems. Anyway, you may have noticed that, our research actually addressed the challenges in transportation from a systemic type of perspectives. And our research actually seeks to enhance transportation modeling to develop a complete picture of the broad impacts of transportation and trying to find out the best ways to manage the transportation systems. Here in this slide, you can show that there are 4 main research directions. The first one is the smart transportation systems that's closely related to my research expertise, which focuses more related to the impact of innovative technologies, such as driverless vehicles, connected vehicles, and electric vehicles. The second research direction focuses on the freight demand modeling, focusing on the development of new economic models to understand and analyze the decision makers' behavior and facilitate the policymaker to conduct their policymaking process. The third research direction related to transportation data analysis. It emphasizes the importance and the power of data, which can be collected from the real world much easier in the future using different type of ITS devices. We seek to use the various data analytic approach to address the issues related to mobility, safety, and sustainability in transportation. The last research direction related to the disaster response logistics, which focuses on the development of novel disaster response procedures using the collected data and behavior modeling, as well as simulation. Next slide, please. So our research group believes that that's very important to have an appropriate balance between theory and practice. Therefore, after joining the program, all the students will work on some research project to find a topic which has a potential for original, substantive, and meaningful contributions. This slide just shows some project currently still ongoing in our program. And our program just received a lot of support from international, national, and state funding agencies. As you can see that several of them actually cover a wide range spectrum of these topics. They can cover either related to the real world implementation. For example, here, the very last one, and that's supported by US DOE, and we're trying to conduct research to understand the energy efficiency of a corridor that connects from the New York City to our local capital region. and we try to do fundamental research, develop models, collect data, and do some pilot testing, so that we can help the freight system further improve their energy consumption efficiency. We also conduct research more related to the theoretical side that also has been supported by National Science Foundations. And this is just a list of our kind of project. So certainly that may have your interest. If you do, then you can contact all our professors in this program, and then we certainly would like to help you to have further understanding of our research. Thank you.
All right, thank you very much, Sean. Our next speaker is Professor Al Nagar to discuss structural engineering.
Hey, good time, everybody, wherever you are, all around the world. My name is Mohammed Al Nagar. I'm an assistant professor in the Civil Engineering Department, Civil and Environmental Engineering. The structural engineering group includes Professor Chris Litchford, who is the department head and who's an expert in wind engineering, Professor Mike Simmons, who's our host today, and who's an expert in earthquake engineering and control, Professor Mike O'Rourke, who's also an expert in earthquake engineering, pipelines, and snow loads, and myself, Mohammed Al Nagar, and my expertise is in experimental and computational mechanics of construction materials and structures. Next, please. So to give you a brief introduction of what we do here, we cover the two wings of structural engineering, the load and resistance. On the load side, Professor Litchford works on wind load mitigation and minimization. He also covers smart development of bluff body aerodynamics with biomimicry of buildings, so trying to biomimic the shapes that are present in nature to reduce wind loads, and a combination of control tools to improve the aerodynamics of wind loading. You will probably hear more from Ali, who is one of his PhD students, and he's with us here. Professor Mike O'Rourke works on snow loading. He's an expert in that field. He has significant contributions to the snow load codes nationally and internationally. And he also has worked on lifelines, basically period pipelines behavior in seismic, under seismic loading, which combines a collaboration between the structural group and the geotechnical group using the centrifuge facility, which is a unique facility that we have here. I'll be talking about facilities soon. Next, please. So on the seismic design and improved performance side, Professor Simmons is an expert in that field who has performed analytical and experimental studies for seismic response and control of structures, passive and hybrid control, with patents, with very challenging and very interesting research works with full-scale testing, covering a wide range of earthquake engineering problems and mitigation methods. And my personal research is on infrastructure materials, mostly cementitious materials. I have some work on steel corrosion, but mainly I use multi-scale, multi-physics computational modeling, and I develop those models to represent advanced cementitious materials like ultra-high performance concrete. I also do microscale chemomechanics of cement. I study the cement at the microscale, how aging and deterioration manifest at the fundamental scales inside the material and how that affects the structural behavior. So the two lower drawings show modeling with multi-scale modeling, so the ability of reducing the computational cost by using different mathematical models. And recently I developed a novel concrete 3D printing technology. And my work on concrete 3D printing is both technology development and computational modeling of the overall process. So these are the research directions that we have in a nutshell. We have a number of graduate classes that support our research that include design classes for advanced concrete, advanced steel design, timber, and masonry design. We also have classes like conceptual structural design, which gives you an idea of how to conceptualize your structural design. We have collaborative work classes like the Bedford Seminar and Bedford Studio, which allows you to work in an environment with architects and towards the common goal of making a real building. We also have analysis and mechanics oriented classes that are fitting our group expertise. We have earthquake engineering, structural dynamics, nonlinear structural analysis, and we have advanced concrete mechanics, which is fracture mechanics based. And our students typically take either finite element analysis, which is a cross-listed course between us and mechanical engineering. And we also have solid mechanics classes, and we have also some other classes that you can take, numerical methods if you're interested from the, if you need your, to improve your numerical modeling, computational modeling capacity. We have classes that our students have taken from mathematics. So we are a broad working group. We have research from very practical applied work to very sophisticated, let's say, or a very detailed basic research funded from different agencies and with recent interests. With this, I would stop this part.
Okay, thank you very much.
Thank you.
So we move now to research labs and facilities, and Professor Al-Nagar will also speak on that.
Okay, so now I change my hat. RPI has a wide range of facilities. We are known by multiple big research centers, and the most important thing I'd like to say about RPI is that our work is very collaborative. We have what we call low boundaries. So we work in collaboration with mechanical engineering, with School of Architecture, with a center called CASE, Center for Architectural Science and Ecology. Professor Marianne, for example, when she was speaking about work on the food and light, she's collaborating with the Light Center, which is part of the school-wide centers. So we're very collaborative. We enjoy the use of multiple facilities, and one of the major big facilities that we have at RPI is AI MOS, or AMOS, which is a supercomputing system that is the most powerful university-based supercomputer in New York State. And it's ranked #1 among supercomputers at the private American universities. We also have a unique geotechnical centrifuge facility at RPI, and we're talking about being the second, or if my colleagues here in geotechnical engineering can correct me, we're either the second or third top-ranked geotechnical centrifuge in US. We have in-flight 2 and 4 degree of freedom robots, means that they can move in 4 directions. We can reach up to 150 G-ton centrifuge, means 150 times the gravitational acceleration. Next, please. We also have a medium scale shaking table, which we use for different research topics. Currently, I'm working with Professor Simmons on testing lightweight structures made out of bottles, plastic bottles, on this shake table. So it doesn't look like this now. It has plastic bottle panels on top of it. We also have a medium scale wind tunnel, and we have a gallery of concrete testing and conditioning equipment, and we have 4 different mechanical testing machines. And with this, I'd like to thank you, and I think that's it. So
thank you very much, Mohammed. Really appreciate
Thanks.
it. Our next speaker is going to be talking about his experience as a graduate student at RPI. Ali, you have the floor.
Yes, hello everyone. Thank you for tuning in. My name is Ali Merhi, and I'm a PhD student in the Department of Civil and Environmental Engineering. I'll be mainly talking about the experience as a graduate student with some personal experience as well. Just to give you an insight, my research is focused on wind engineering. I started with doing research on thunderstorms by comparing the characteristics between thunderstorms that happen in Italy and Texas and apply them on tall buildings. And lately I've been involved in research in database assisted design for low-rise buildings in hurricane-prone regions. And my advisor is Dr. Lashford. I think when I say the following, most or all graduate students agree with me on this in my department, is our work really so far is focused with clear targets. Every year, the graduate student and his advisor or her advisor sit down and define the goals and targets with strategy to achieve throughout the year. And this is very helpful to pave the road for the work, particularly during the first year or two. For example, my advisor and I, we select the courses, the graduate courses that we should take, not only based on what they provide for research, but also based on nourishing the critical thinking, which is very important for problem solving and research. And I have to say the graduate courses that I've taken with my fellow graduate students were all challenging, but at the same time stimulating. They were really enjoyable because something nice about it is the professors are very resourceful. So the professors here in the structural department know how many times I walk into their office and we talk about not only discuss the problems that are presented in the homework or exams, but also brainstorm and discuss ideas, which is very constructive. This is in terms of coursework and research. Fundamental thing that helped me at least was participating in workshops, symposiums, and conferences Now, unfortunately, with COVID, we're doing everything remotely, but when everything was normal, participating in events like these was very helpful, not only to understand what other fellow researchers and graduate students from institutions are doing, but also for networking, which built for collaboration and to provide other ideas. And for example, I had the chance to meet in one of the conferences. I met a managing director in the Insurance Institute for Business and Home Safety, where I did my internship remotely during the summer, and this built for a collaboration that we're maturing right now. And in terms of support, I have to say that the department and the institute have been very supportive about the teaching assistantship. So for example, I had the chance to join with teaching assistantship, which allowed me to not worry about the support, but just concentrate on the research. And now after years of intensive research, we got the chance to build on for a research project, and hopefully everything will be fine. I think this is to give you everything in brief as my experience overall. But if you have any other questions or things that you're curious about, I'm happy to answer them at the end.
All right, thank you very much, Ali. Okay, so that brings us to the end of the presentation, and now we have a question and answer period. If anyone has any questions, I was looking at the chat, and the only question in the chat that I don't think has been answered yet is about how to apply for teaching assistantships or research assistantships. And the answer to that is that on the application, there's a place to specify whether you're requesting financial support. And from that, we know whether you're looking to serve as a TA or an RA. So that's where you would do that. If anyone has any other questions, feel free to ask in the chat, or feel free to unmute and ask in that way as well. Either way is fine. So I don't know, maybe Mary Kate, maybe you can answer the one that just came in.
Yep.
Or maybe not, I'm not sure. So
yeah, I think that's maybe a question better for you. So the departments evaluate applications, and it's really about their timeline and the turnaround time for each department. So I think that's a better question for all of you.
Yeah, well, and I'll just say that the question that was asked is, when will the decision be made on an application? And we review applications on a continual basis, and we try to make decisions as quickly as possible. And so we start that process shortly after the deadline for applications to be submitted, which I remember is January 1st.
Yes.
Yes. And so we get rolling with that shortly after that, and start making final decisions as early as mid-January, say. And then we continue to do that as we make offers to students. As those offers are either accepted or declined, that opens up spots, and then we may continue to make additional offers. So that's the basic process.
So there's another question in the chat, and I think that this is a good thing for us to elaborate on, is what funding looks like as a whole. So are PhD students funded? Are master's students funded? We spoke a little bit about the application process for that, but I think it would be good for us to talk about what the funding looks like for PhD versus master's students.
Yeah, I guess I could say most funding goes to PhD students or applicants. And as an institute, RPI generally does not provide financial support for master's applicants. But that, and what I'm saying very specifically there is that RPI itself does not provide financial support, but faculty may have projects with external funding sources on which they may support a Master of Science student. So it is possible to get funding as a master's student, but it requires that there's a project that one of the faculty members has and is able to support a shorter duration. You know, a master's project is typically I'd say 1.5 to 2 years, and so that's a shorter duration than the PhD. But there are some external funds sometimes that have a limited time frame, and they're ideal for supporting a master's student.
Mike, I'd like just to add a quick clarification for this from my side. So for students, for international students, some students think that they have to have a master's degree before they apply to a PhD degree. This is typical in many places in the Middle East, for example. So just to clarify, for us here, you don't have to. So if you're just applying for a master's because you don't have a master's and you think you have to apply for a master's first before you apply for a PhD, you don't have to. If your end goal is a PhD, then directly apply to a PhD. You don't have to start by applying for a master's. Just an explanation.
Let me just, I think the way you explained that, I got a little confused there. So let me just summarize it. You know, if your ultimate goal is a PhD, then we encourage you to apply directly to the PhD program.
Yes.
Even if the only degree you currently have is a bachelor's degree. And in this way, we can immediately consider you for funding that will support a PhD student.
Thank you.
Okay. I'm just checking through the questions here. No, I think we've answered all of them so far. Are there any other questions out there? Good question. How are students selected for admission and funding? Yeah, and is it based on the GPA or the GRE? So we, in general, we consider certainly the GPA, and we also consider GRE scores, and we have other criteria we look at in terms of looking at your overall background and how well we think you would be able to contribute to the research program that we have in the different areas of concentration in the program. With regard to the GRE, for the, maybe I shouldn't say that. I've been told that it's possible that the GRE may not be required for applicants for the fall 2021. I don't know, Mary Kate, do you know if that's a fact now? I only heard that it was a possibility.
It is, yes. So for fall 2021 only, it is an optional component to the application. Yep.
Okay, so it's an option whether you report GRE scores or not. Speaking personally, I would encourage applicants to provide their GRE scores. It's another piece of information that we can use to help make decisions. So hopefully you do well on those and report those, and it helps us to provide support to an application. Okay, another question is, do I have to contact a potential advisor ahead of time for a PhD? The answer is no, it's not required. On the other hand, it's often the case that those who apply to the PhD program have already looked at what the faculty within the area of concentration are doing. So for example, in structural engineering, we have 4 structural engineering faculty members, and we're all doing different things. And you can do a little bit of research to figure out what we're doing and perhaps identify someone that you'd like to work with, and then make a personal contact with that faculty member to inquire about whether there might be projects that you could potentially work on. I don't know what else to add to that. And so anyway, just to summarize, there's no requirement to do that. Sometimes we get applications certainly where that applicant has not contacted any faculty member. And based on the application, we can get an idea of what faculty member might be best suited to work with that applicant.
Mike, can I answer Belinda's question?
Oh, yes, please. I just was reading that. Yes.
I'm sorry. Hi, Belinda. So you're asking how many students are we taking in environmental engineering program for this fall? And I can't give you a specific number. It really depends on the funding situation. It depends on TAs, how many students are graduating. So for example, I have 1 student graduating. So I'm hoping to take at least 1 student, probably more, but that's kind of like where we go. So it's not a set number for each year or each semester. It really depends on many different things. So I hope I answered your question.
Great. Thank you, Marianne. I'd like to go back to the question about the GRE, because I just noticed what was asked was, if you don't have GRE scores, will that be a disadvantage? The reason we're making it optional for the fall is because of the pandemic and recognizing that some students or applicants may have difficulty taking the exam. That's my understanding as to why we're doing that. And so I would say that, again, if you're able to take them and earn high scores, that's an additional piece of information that will be useful to us. And if you're not able to take them, then we will do the best with the information you do provide to make a decision on your application. And you can see in the chat that Professor Letchford, the department head, has recommended that you attempt to identify a potential advisor if you're planning to pursue a PhD or even a master's degree. And he recommends doing that before you apply. Okay, I think we're caught up now on the questions. Oh, we got another one from Nadia. How long does it take to receive? Yeah, we mentioned something on this previously. We evaluate applications again, beginning in approximately mid-January. We're starting to review them and having meetings to discuss the applications and make decisions. And the applications are ranked and offers are made for financial support and for admission. And then we sort of have to wait to see which applicants accept our offer for admission or financial support. And then once those decisions are made, we can then go on and perhaps make additional offers. But there's of course a finite number of, a finite amount of financial support that we can provide. And so we're working within that constraint. And our goal in the end is to fill all available teaching assistant positions and research assistant positions. And that sometimes takes time. As I say, we may make offers sometime in January, and then we have to wait a little bit for those applicants to make their decisions. And so it takes some time before we get the second, maybe third round of offers out the door. And so that's a process that may take some time. But typically everything is done. All positions have been filled at the very latest. I believe the final date that's done, those decisions are made is April 15th. But we try to do it much sooner than that. We try to fill all the positions as soon as possible. Okay, so somebody asked, is it possible to apply for a PhD if you only have a bachelor's degree? So we did address that issue previously, and I just want to take the opportunity to mention it again. This is very important. We often have strong applicants that have a bachelor's degree but do not have a master's degree, but their ultimate goal is a PhD, and we encourage them to apply directly for the PhD. In that way, we have better ability to provide financial support. Oh, and I see that, I just saw, Mary, that you responded to that. Okay, and then another question is what do we expect to see in the statement of purpose? And that's an interesting question. I don't know if we give any kind of guidelines in the application for what should be in the statement. Do you know if we do, Mary Kate?
Yes, I can speak a little bit on that. It's important to describe and explain your goals, why you're interested in pursuing the degree that you're looking for, why the specific program. So showing the professors in the department what it is about the research that's done, about our curriculum that intrigues you, and why you want to attend our school. It's also good to speak on your prior experience. So especially with a PhD, what sort of research you've done to prepare you to transition into a PhD research program. And then lastly, we like to encourage students to address any shortcomings that they might have. So if you had a semester where your grades are a little bit lower or less consistent with the rest of your transcript, we really encourage you to address and explain what happened. Maybe you had a very difficult course. Maybe there was a reason at home with your family that you had to leave campus for a few weeks, or things of that nature that give the admissions and the department committee a deeper understanding of why your grades may be lower than they typically would be. So those are really the main components. We overall say it's a professional conversation that you're having with prospective academics.
Yeah, I think what you just said hit on, all the things I would be looking for in the statement. I don't see any other questions at the moment. There, one just came in. Oh, it's an interesting question. Is it possible for PhD students to design an interdisciplinary research if I have an outside source of funding? I'm not sure about that. I assume that anyone who has their own source of funding, we would certainly be interested in talking to you about how we might be able to use that funding to help you earn a graduate degree at RPI. So I'm not sure about the details of it, but we certainly would like to have a conversation about it.
Mike?
Yes.
So it's Marianne. So what I do, I collaborate frequently with other universities. So my students go and visit like Cornell for in this case, and they do research at Cornell. But the funding directly comes from RPI, so I don't know that portion of it, but we, all of us have connections that we can use to accommodate the best we can.
Okay, thank you.
Mike, perhaps I could jump in there as well. I mean, we have a very active science and technology studies group on campus in humanities, arts and social sciences. And there are possibilities for doing interdisciplinary graduate work between engineering and say that program, science and technology studies, or engineering and management, or engineering and economics. So there are opportunities for multidisciplinary programs. My own research straddles mechanical and civil engineering. So I've had students that I've supervised that are actually in mechanical engineering as well.
Thank you, Chris. All right, so it looks like Mary Kate, you just answered the last question there, and we've hit the 3 o'clock mark. So I'd like to end the webinar, but for those of you who are out there, if you have any additional questions, you should contact the relevant graduate program director, which is myself. As you see on the slide, it's myself for the civil engineering program, which includes transportation, geotech, and structures. And it's Professor Nyman for environmental engineering. So you can contact either of us, and then we can refer you to whoever might be specifically able to answer any questions you may have. And also, if you have any questions about the admissions process or something that would be answered by the Office of Graduate Admissions, you can contact Mary Kate Scardillo. And so our email addresses are all on that slide. And so to close up the webinar, I'd like to, first of all, thank our speakers. Really appreciate their help today. Also want to thank the Office of Graduate Admissions for helping to organize this webinar. And to the students that are in attendance, I want to wish all of you good luck in your search for a graduate program that meets your needs. We certainly hope you decide to apply to become a graduate student at RPI. Thanks very much and have a great day.
Thank you.
Thank you,
Thank you,
Mike.
everybody.
Thank you. Have a
Thank
good
you.
day.